We're going to work on distance formula now. So this is the bottom of the front of Unit 6 chart. So distance formula comes from Pythagorean theorem, and what we did in class was I showed you how it ends up coming from Pythagorean theorem, because if you had a little graph, I'm just sketching this, if you had those 2 points and you were asked to find the distance or the length of that line, what you would end up doing would be to make a right triangle out of it. And this length right here you would find by subtracting the two x values. And then this length right up here, from here to here, you would find by subtracting the y values. And then using Pythagorean theorem, we would say, well, this side squared plus that side squared would equal that side squared, which means that this would be the square root of that answer. So that's where the x minus x squared, that's your a, side a, squared. And then y minus y is your b squared. And then you add those together to get c squared. So to figure out c, you need to take the square root. What it does, it helps us prove if sides are congruent or not. Because if their distance is the same, that means their length is the same, which means that they're congruent. So number 4, easy one, just find the distance from those 2 points. So the distance between those 2 points, we need to do square root. So the distance between 1 and 3 is 2. So that's 2 squared, plus the distance between -2 and 8 is 10 squared. That is going to give us 104, because that would be 100 squared. I went a little crazy. 100 squared plus 10 squared, which is 100, plus 4, which is 104. And then since we're finding length or distance, my guess would be that they're going to estimate that. So if you remember how to estimate, I would probably say this is somewhere around 10.2. That was from Math 8. All right, moving on to number 5. We need to classify whether this triangle made from these points is scalene, isosceles, or equilateral. So what we're going to do is use the distance formula, find the length of each side, and then we can say what kind of triangle it is. So my 3 sides are xy, yz, and xz. So what we need to do is find the distance or the length of each side. So for xy, the distance between 1 and -1 is 2. Square that, you get 4. The difference between -1 and 4 is 5. Square that, you get 25. So xy is the square root of 29. And it's not asking me for the length. It's not a perimeter or area question, so I can leave my answer right there, because all I need to do is compare. So now we need to do yz. So from 1 to 5, that would be 4, squared would be 16, plus the difference between -1 and 2 is 3, squared is 9. That adds up to 25. So now I need to find xz, because I know right now equilateral is out, because those two are different lengths. So now I need to either get the same answer again to make it isosceles, or a different answer would make it scalene. So x to z. So from -1 to 5 is 6, which is 36. So I can already tell the answer here. And then the difference between 2 and 4 is 2, squared is 4, makes that length the square root of 40. So now I know that this is a scalene triangle. All right. Number 6, determine if point P is inside, on, or outside of circle C. If C, which is the center, is right there and it contains point A. So what that tells me is that from C to A, that's called the radius. So what I'm going to do first is figure out how long, the distance, the length of the radius. So from -2 to 0, that's 2, squared is 4. From 5 to 10, that's 5, squared is 25. So that tells me that the radius is the square root of 29. Now what I need to do is find from the center to point P. And if I get the square root of 29, then I know that P is on the circle. If I get something smaller than the square root of 29, then I know that P is inside. And if I get something larger than the square root of 29, then I know that P is outside of the circle. So, C to P. So 2 to negative 2 is 4, squared is 16. From 1 to 5 is 4, squared is 16. That is the square root of 32. So if you can imagine what this looks like, here's C, here's A. So C and A is right here, and this length is the square root of 29. P is the square root of 32 away from, square root of 32, away from the center. So that tells me that P is outside of the circle. All right, moving on. Let's see if we can get these two done. Find the perimeter of the shape formed by A, B, C, D. So in order to find the perimeter, I have to find the length of the four sides and then add them all together. So first thing I'm going to do is list the four sides. So A, B, B, C, C, D, and then D back to A. All right, so the difference here is 7 squared is 49. Difference there is 1 squared is 1. So this is the square root of 50. Now, since I'm finding perimeter, I do need to finish these. So I would say 7.1 because that's just after 49. All right, BC, 2 to 6 is 4, square that. 7 to negative 1 is 8, square that. Add these together, I get square root of 80, which is just under 9. All right, CD.
It's still not working after you put that.
Sorry for the interruption. We'll blame Zach Brennan. Anyways, okay, so CD, he wanted to be on the video. All right, so the difference between C and D, so that is 9, square that, we get 81. The difference between negative 1 and negative 1 is nothing, so square that, we still get nothing. So this is the square root of 81, which means that side is 9. And then AD, last one, from negative 5 to negative 3, that's 2 squared. From 6 to negative 1, that's 7 squared. Add those together, and we get the square root of 53, which I'm going to estimate to be about, sorry, got distracted, 7.3. So now if I want to find the perimeter, I just need to add all of this up. So that right there is 16. 16 plus 9 is 25. 25 plus 7.3 would be 32.3. So that is your perimeter. Okay, last question. Rhombus has 4 congruent sides. Show that this shape is a rhombus. All right, so what we have to do is show that we get the same thing on the 4 sides. So first thing we want to do is label the 4 sides. And then W connects back to Z. All right, so WX. So from negative 5 to 3 is 8 squared is 64. From 6 to 7, that's 1 squared is 1. So this is the square root of 65. XY, from 3 to 4 is 1, squared is 1. From 7 to negative 1 is 8. Square that, you get 64. So those two sides are equal, so far so good. All right, YZ, from 4 to negative 4 is 8, square that. From negative 1 to negative 2 is 1, square that. And again, we get the square root of 65. And W to Z, so just be careful. From negative 5 to negative 4 is 1, square that, you get 1. 6 to negative 2 is 8, square that, you get 64. Add that together and you get the square root of 65. So all 4 sides are the same. So we could say 4 congruent sides. All right, that covers all the ways that we can use the distance formula.